Okay, good morning, ladies and gentlemen. In this session, we are going to discuss measurement of age, and secondly, we'll look at causes of errors in age measurements, and how do we detect the errors, and lastly, the process of adjusting age data. So normally, when we look at the measurement of age, we know that we measure age in years, and normally when we are measuring age in years, we use what is called an age structure, and the age structure is normally represented in intervals of 5. So we can actually say 0 to 4, 5 to 9, 10 to 14, etc. So normally this can be defined by gender, considering the difference between males and female. So whenever we want to represent age groups, we actually use them the age structure as a proxy way of defining the ages. So that's the most important situation that we need to know. And secondly, when we have got the age, sometimes we can actually use the age to actually present information in what is called a pyramid. And a pyramid is actually a graph that actually try to explain the differences in the growth pattern between men and the women. And we can actually have a 0 here like that, 5, 10, 15, and 20, and 5, 10, 15, 20 on the other side. So let's assume this is the size of the population. So it means that these ones are in a scale of maybe 1 million. So it means that this is 5 million, 10 million, 15 million, 20 million. And then on that, we can be able to have a corresponding presentation now of the ages, and which can be like maybe 10, and here 20, here 30, here 40, here 50, here 60. So this can be like an age. So if, for example, we have got children ranging between 0 and 10, they are 15 million, and for female, so we can be able to draw like this. And if we have them as maybe 10 million for the other part, then we can be able to draw them like this. So at the end, we can actually have a different population. Like in this case, we can actually have it as bigger, and then like that, and then like this, and then like that. So what you can see is there are some variations in as far as the age is concerned. So like for this population, it means that the age is becoming smaller as we are increasing. And for this one, it is here, and then it meant that the age group between 10 to 20, it's a bit bigger, and then it is becoming smaller, and then it is becoming bigger again. So this distribution is actually called a population pyramid. So it is a population pyramid. And the population pyramid, it is used to actually show us like a age structure of the people. And the stories that it tries to explain is it can explain how people are dying, which is mortality, and it can explain how people are being born, which is birth history, and at the same time it can explain how people are moving up and down, which is migration. Now, if you can look at different countries, they normally have got a different population pyramid. For example, we can have population pyramid for Europe, which can be different from a population pyramid for Africa, and even population pyramid for Asia. Now, most of these countries, Europe and Asia, their population pyramid is bigger at the top. It is like this, bigger at the top. It is different from an African one, which is bigger at the bottom, which is like this. Why? Because the Asian population, we actually call it as an aged population. So we actually call this population as an aged population, whereby for Africa, because it is inverted like this, as shown, it is actually regarded as a youthful population. So in terms of the economic participation between the two countries, it could differ, because here you have in Europe you have got so many people that are older who are in the taking part in the formal sector economy, relative to African context, where majority of the people are youthful dependent, and most of them, they are consumers and not producers of resources. Thereby, we have got very few people in Africa who are working relative to the ones in Europe. That's why we have got variations. Now, the bigger the number of people here, the more the economic activities, the more the industries they have, the more organized they are, whereby it's vice versa from an African context. Okay, so having said that, I want you to actually check on the population pyramid, just make comparison population pyramid for Latin America. How is it different from a population pyramid from Africa and a population pyramid from Kenya, from Europe, so that you can actually make a big contrast on the way the population can be defined. Now, another way that we can look at is when measuring population, we always have got errors that are associated with the population. Some of these particular errors, they can be determined by the people whenever they are reported their like ages. For example, people normally when they are reporting ages, they can actually have they can ignore or they don't know their age. So it's an issue of ignorance, which makes them not to give the correct age. And secondly, we have got people that are careless in reporting their ages. So there is an aspect of carelessness in reporting and at the same time recording their ages. And thirdly, there is a general tendency to state the age in figures ending in a certain preferred digit. Okay, so like for example, if I am 37, I can say I am 35. If you are 47, you can actually say I am 50, depending on which digital preference do you require, which normally gives in error. And sometimes there is a tendency of exaggeration. People, they can be able to exaggerate the length of life, for some economic gains. So they ended up giving the wrong data. And at the same time, people deliberately can do what is called misstatement, arising from the motives of an economic, social, political, or even purely personal character. Okay, so it can be for political reasons, it can be for economic reasons. Maybe you want to cheat the age so that you can continue working, or it can be for social reasons. Maybe you wanted to marry somebody very small. You can actually tell them, say, I am 27 when you are in fact 40. Maybe because you have got structurally, you have got a very small body which looks young. So for those reasons, people can end up reporting error when which can be attributable to age. Now, so most of the time, the causes of age misstatement are common most demographic investigation. Mostly in Africa, people we actually tend to cheat a lot or to misstate a lot on the ages. And because of that, we have got deficiencies in as far as how we can be able to report on data, and that affects even the quality of data that exists in Africa. Now, for example, because most of the people in Africa, they don't have like education-wise, they don't know the importance of specifying their specific ages, then the data itself has a lot of issues. That's why most of the time, data that we generate in Africa, people, they don't trust it so much relative to high precision of data which is collected because of a high level of accuracy which defines the data. So that's the most important part. Now let's look at quickly methods of detecting error. Now we have got different methods that we normally use to detect the error in a demographic environment. One method is actually called the age ratio. The age ratio. So the first one is called the age ratio. Okay, and the second one is actually called the sex ratio. So we have got the age ratio, and the number one. Number two, we have got the sex ratio, which we discussed last time, and number three, we have got the age and the or a sex accuracy index. Okay, so we have got the age or sex accuracy index. Now from the age ratio, at this moment we can be able to define it as the following equation: 5px over half bracket 5p x minus 5 plus 5p x minus plus 5, and this one you put it in a bracket multiplied by 100. So the radix is always 100 in this particular scenario, where in this case 5px, this is actually the age group of interest, which is measured demographically from x to x plus 5. So it could be any age group in that particular level, as long as the corresponding age it is x minus 5. It means that you are taking subsequent age, and then you are taking x plus 5, which is a following up age. So it means that if you have got age 0 to 4, 5 to 9, and 10 to 14, this one is x, this one is x plus 5, and this one is x minus 5 age. So you can actually, if you have got the ages like population here, x, y, and zeta, then you can be able to say population for that one for x is y over population for this other one is now x plus z, and then this one is the one that you're going to multiply 0.5, which is half, and then you can multiply by 100, so that you can specify the age ratio that you want. Now the computation of age ratio are then compared with the expected value, which is usually 100. So you actually compare with 100. Now the discrepancies that can be detected in that particular level, that's when you can understand whether the population has error or not. That's the most important part. Okay, so we are going to continue in the next session by discussing the sex ratio, and at the same time by discussing the age sex accuracy index. I thank you for your attention as we are continuing in the next session. Thank you.